We continue to work with our understand, solve, and explain strategy. Example 4. Visible light has an average wavelength of about 500 nanometers. What is its frequency? As always, step 1 is understanding the problem. The speed of any wave must be its wavelength times its frequency, because the wavelength tells you how long each wave is, and the frequency tells you how many waves pass a point each second. Therefore, for light, the relationship is wavelength times frequency equals the speed of light. As usual, we use c to represent the speed of light. We are given the wavelength of 500 nanometers and asked to find the frequency, so we need to solve the equation for frequency. We can do this by dividing both sides by wavelength. Wavelength then cancels on the left, leaving the equation frequency equals c, or the speed of light, over wavelength. Let's rewrite this to make some room. We're now ready for step 2. Recall that the speed of light is 300,000 kilometers per second, or 3 times 10 to the 5th kilometers per second. We divide by the wavelength of 500 nanometers. The only problem is that we have length as kilometers on the top and nanometers on the bottom. We need consistent units, so let's convert both to meters. On the top, we multiply by 1,000, or 10 to the 3rd, meters per kilometer. The kilometers then cancel. On the bottom, recall that nano means 1 billionth, or 10 to the minus 9th, so 500 nanometers is the same as 500 times 10 to the minus 9th meter. We can do this one without a calculator. First, we put the denominator in scientific notation. 500 is 5 times 10 to the 2nd power. Multiplying 10 to the 2nd by 10 to the minus 9th gives us 10 to the 2 minus 9, or 10 to the minus 7th. Note that the meters now cancel in the numerator and the denominator, leaving the final units of per second. For the numbers, we have 3 divided by 5, which is 0.6, and multiplying the powers of 10 gives us 10 to the 5 plus 3 minus negative 7, which is 10 to the 15th. Finally, we can rewrite 0.6 times 10 to the 15th as 6 times 10 to the 14th. As we've seen, the units are 1 over seconds. To explain the answer, we must think about the units. 1 over seconds are what we often say as cycles per second, or hertz. So we found that the frequency of visible light is about 6 times 10 to the 14th, or 600 trillion hertz. If you recall that we use the prefix tera for a trillion, you can also say that this is 600 terahertz.